Hello. Today's lesson's on using the second derivative to determine if a critical point is a min or a max. Okay, so far in this lesson, this unit, we've done the MVT, mean value theorem. What tells you is the average equals the instantaneous. Okay, we've done the EVT, which is extrema on a closed interval. Okay, we've done first derivative test, which is this. It says if the first derivative is positive, f is increasing. We've done, and if the first derivative is negative, it's decreasing. And we know if the second derivative is positive, it's concave up. And if the second derivative is negative, then it's concave down. Okay. If the first derivative is 0 or doesn't exist, it's called a critical point. Okay, that critical point might be a min or a max. You have to make your table and your chart and check. If the first derivative changes from positive to negative or negative to positive, you're going to have a min or max. And then we also did, if the second derivative is 0 or doesn't exist and it changes sign, it's called a point of inflection. Okay, that was the second derivative test. This is not really. This is, well, yeah, the second derivative test is going to help us determine if a critical point is a min or max. By using concavity. Okay? What it tells us is that f of c, the first derivative is 0, and the second derivative exists. If the second derivative is greater than 0, then f of x has a minimum at c, and f is concave up. Think about that, right? If you graphed a function and it's concave up, and this point right here has a first derivative that's 0, it's the bottom of the curve, it's a minimum. Okay? If the second derivative is less than 0, it's negative, you know it's concave down, and you have a maximum. Here's your graph again. Concave down, your first derivative is 0. It's on the top of your curve, so it's a maximum. If the first derivative is 0 and the second derivative is 0, then f of x is neither. Then f of c is neither. And you're going to use your first derivative test. Okay? So let's use that first derivative test to find relative extrema. So you take the first derivative, you get 1, let's see, minus 2 over x squared. Is that right? And set it equal to 0. So you have 1 equals 2 over x squared. So x squared equals 2. So x equals plus or minus the square root of 2. All right. Now, rather than making my chart that goes from negative infinity to negative root 2, okay, we're not going to do that. We're going to find the second derivative. Okay, so the second derivative, remember this is negative 2x to the negative 2 is f prime. Ugh, that's just awful. Let me fix that handwriting. Sorry. That's f prime of x is equal to that. So f double prime is 4 over x cubed. Now, you take your critical points and put them in here. You get 4 over the square root of 2 cubed. Is that positive or negative? It's positive. So the function is concave up. And square root of 2 is a minimum. Okay, f double prime of negative square root of 2 is 4 over negative root 2 cubed, and that's negative, so it's concave down, and negative root 2 is a maximum. Every time I do that, I use my hands, make the picture, decide if my dot's on top or underneath it, okay? All right, let's look at this. This is just a little bit easier. It's a polynomial. So you take the first derivative, negative 3x to, no, sorry. Sheesh, I'll try and focus. Negative 15x to the fourth plus 15x squared. I have to set that equal to 0. So let's factor out negative 15x squared, and you're left with x squared minus 1. So I have x equals 0, and x equals plus or minus 1. Now I'm going to take the second derivative, and I get negative 60x cubed plus 30x, and I'm going to plug in these values. So if I plug in 0, I get 0, so it's don't know. It's neither. Okay. If I plug in positive 1, I get negative 60 plus, negative 60, not 16. My plus 30 is negative 30, so it's concave down. X equals 1 is a max. If I do f double prime of negative 1, you get positive 60 minus 30 equals 30. It's concave up. X equals negative 1 is a min. Okay, I'm going to try something here. Oh, no, that's not what I wanted to do. Sorry. I want this, and then I want to do this. Oh, hang on. Sorry, I'm trying to be tricky here. There we go. All that to try and show you something. If I type this in, negative 3x to the fifth plus 5x to the third, close that. All right, here we go. Okay, so here I have negative 1. I said it was a minimum. Is it? Yep, it's a minimum. It's the bottom of my curve. Is it concave up? Yes. At 1, it's a max. It's concave down. Here, it's not a min or a max. Okay, so it's neither. It is a point of inflection because I'm concave down and I'm concave up. All right, pretty nifty. All right. Little side note, when you're working on your quiz, you put your function in and you got to know where it's increasing and decreasing. We're decreasing, we're increasing, we're decreasing. Okay? You can look at the graph and then use your calculus to show that it works. Okay? All right. Let's see. Go back to... We don't want to do that. Sorry, you just have to deal with me today. All right, where were we? There we are. Okay, back to the notes. All right, using the second derivative test, find the relative extrema. That's another one. You can do that by yourself. All right, suppose the function f has a continuous second derivative for all x. F of negative 1 is 2. F prime is a negative 1 is negative 3, and f double prime a negative 1 is 5. That g be a function whose derivative is given by, write an equation of the tangent line to the graph of f at the point where x equals negative 1. Before we do that, I want to ask you is, all right, so, nope, I'm changing my mind. All right, they told me that's the derivative. Dang it. That's the derivative. Write an equation of the line tangent to the graph at the point. So we have to find the derivative at negative 1. So that's 1 minus 6 times 3 times f of negative 1, which is 6, plus 2 times f prime. So that's negative 2. All right, negative 2. So you get negative 5 times 4 equals negative 20. Then what? We're going to tangent line to the graph of f at the point of 1. What was the point of all that? That's the slope on g. We didn't need to do that. The equation of the line tangent to the graph f at the point where x is negative 1. Well, this is just ridiculous. Here's your point, here's your derivative. Y minus 2 equals negative 3 times x minus 1. I think that question was going to ask you something else, and it screwed it up. All right, in the figure below, the graph of f is the derivative of f on the closed interval. The graph has a horizontal tangent line at 2. Okay, so what's that telling me? It's telling you f double prime at 2 is equal to 0. And it's linear on this function, okay? Find the x-coordinate of the relative maxima of f. Okay, this is the derivative. A max occurs when the derivative changes from positive to negative. Positive to negative, so there's x equals negative 1 and x equals 3. All right. This is a minimum because it changed from negative to positive. The points of inflection. Your points of inflection are going to be at x equals 2 because f double prime at 2 is equal to 0. When is f decreasing? It's when it's negative, so negative 1 to 1, and 3 to 3.5. Is f of x twice differentiable? No, because x equals 0.75 is not differentiable. Okay, if the first derivative is not differentiable, it can't find the second derivative here, so it's not twice differentiable. Okay, let h be a twice differentiable function. The first derivative is 0, the second derivative is positive. What's the possible value of h of 3? If h of 0, 0, h of 1 is 2, and h of 2 is 7, okay? This is telling you it's concave up and increasing, so it has to be greater than 7. If it's 12, is it going to cause it to go down? If it's 14, is it going to go up? I think that's your choice. Oh, good answer. Well, the change here went to 2, and then that was 5, and then 5 again. That doesn't keep it concave up. 14 keeps you this way. All righty? Good problems. All righty, think about all that stuff. We'll talk to you later.